Could we make a pocket universe in a lab? It sounds like something from a science fiction movie. A little world in a bottle, a place where its own stars shine, but it's a question people actually think about, even if it's way out there. It makes you wonder what's possible. When we talk about a pocket universe, we mean a new self contained spacetime. Something separate from our own universe. It would have its own laws of physics, maybe. Or it could be a copy of ours, just really small. It would be like hitting a reset button for a whole new reality. And the idea is, could we start one? Like a mini Big Bang right here? First off, it's incredibly hard to even think about. We're talking about controlling fundamental forces, things like gravity, which we barely understand at its deepest levels. And the energy needed? It would be more than anything we can imagine, more than all the power plants on Earth combined by an unbelievable amount. Think about our universe. It started from something tiny, super hot, and super dense. Then it expanded. That's the Big Bang. If we wanted to make a pocket universe, we'd essentially be trying to replicate that. We'd need to create those extreme conditions. We'd need to get matter and energy to a point where space and time itself could form. Right now, our biggest particle accelerators, like the Large Hadron Collider, smash tiny particles together. They do this to see what happens at very high energies. They try to glimpse conditions that were present just fractions of a second after our own Big Bang. But these are tiny glimpses. They are not creating new universes. They are just trying to understand the building blocks of our universe. They are looking at existing spacetime, not making new spacetime. The core idea for making a pocket universe usually comes from general relativity. That's Einstein's theory of gravity. It says that massive objects warp space and time around them. Imagine a bowling ball on a stretched rubber sheet. It makes a dip. That's how planets orbit the sun. They roll in the dip. A black hole is like a bowling ball so heavy it tears a hole in the sheet. It creates an extreme warp. Some theories suggest that maybe, if you could warp space-time enough, you could pinch it off. You could make a little bubble that separates from our universe, like blowing a bubble from soapy water. It becomes its own thing. It's connected for a moment, then it breaks free. This is the Bobby universe concept. But how do you warp space-time that much? You need a lot of energy, and you need it in a very tiny spot. We are talking about energy densities that are hard to even picture. It's not just a lot of energy, it's a lot of energy compressed into something smaller than an atom. Think of a black hole, but even more intense at the very start. And then there's quantum mechanics. That's the physics of the very small. It tells us that things are fuzzy at that level. If particles pop in and out of existence, there's a lot of randomness. Gravity and quantum mechanics don't really get along in our current understanding. They are two separate theories that work really well in their own areas, but not together. To create a universe, you'd need a theory of quantum gravity, something that tells us what space-time looks like at the smallest possible scales, where quantum effects are important. We don't have that theory yet. String theory and loop quantum gravity are ideas, but they are still theories, not proven facts. Let's say we had unlimited energy, and we had a perfect theory of quantum gravity. What would the process look like? Maybe you'd need to focus an incredible amount of energy into a tiny point. So much energy that it would create a singularity like the center of a black hole. But instead of just sucking things in, it would somehow airbound or tunnel into a new dimension. It would open up its own space-time. It's not just about energy, it's about control. How do you direct that energy? How do you make sure it doesn't just destroy everything around it? How do you make sure it pinches off correctly and doesn't just make a bigger black hole in our lab? The safety concerns alone are mind-boggling. Imagine accidentally creating a black hole the size of an atom, but one that instantly starts to grow. That's a bad day. And how would you even know if you've done it? If a new universe pinches off, it would be separate. We couldn't look into it, we couldn't send probes. It would be entirely outside of our reality. The only evidence we might have is that a massive amount of energy just vanished, or that our space-time wobbled in a weird way for a moment. It would be like trying to see inside a balloon that just flew away if you were inside a different balloon. Some people think a pocket universe might be a kind of wormhole that branches off. A wormhole is like a shortcut through space-time. Two distant points are connected by a tunnel. If you could make a wormhole that doesn't connect back to our universe, but to a new one, that could be a way. But even making a simple wormhole is super hard. It needs exotic matter. That's matter with negative mass or negative energy. We don't know if that even exists or how to make it. It's like trying to build something with a material that pushes instead of pulls. The scale of things is just too big for us, or too small, depending on how you look at it. The universe we live in is vast, but at the point of creation, it was smaller than an atom. To replicate that, you'd need to control forces and energies at the Planck scale. That's the smallest possible unit of length, time, and mass where quantum effects and gravity are equally important. It's unimaginably tiny, so tiny that our current instruments can't even get close to seeing it. We are many, many orders of magnitude away. And what about the very beginning? How do you set up the initial conditions? Our universe has certain fundamental constants, things like the strength of gravity, the speed of light, the charge of an electron. These numbers seem to be just right for life to form. If we were to create a new universe, would we get to choose these numbers? Or would they just emerge randomly? It's like trying to bake a cake from scratch, but you don't know what ingredients you need or what temperature to set the oven. And you can't even see the cake while it's baking. We don't just need to create the condition. We need to create the stuff. Where does the matter and energy come from? Does it magically appear? Or do we need to provide it? If we provide it, how much do we sacrifice from our own universe to create a new one? It feels like you need to compress our whole universe into a tiny point to even start. That doesn't make sense. One theory suggests that maybe quantum fluctuations could, under very specific conditions, just pop a new universe into existence. Like how virtual particles pop in and out of existence all the time, but for a whole universe. That's a huge fluctuation. It's like winning the lottery every second for 1,000,000 years. It's possible in theory, but practically impossible. So, where does that leave us? Are we just dreaming? For now, yes, we are. The science fiction movies are way ahead of the science lab. We lack the energy, the technology, and even the fundamental understanding of physics. We don't have a complete theory of everything. We don't know how to unify gravity with quantum mechanics. We don't know if exotic matter exists. We don't know how to pinch off space-time. We don't know how to create the initial conditions. But it's not totally without some scientific thought. There are real physicists who explore these ideas on paper. They use advanced math to model what might happen. They think about the implications. They consider what Bobby universes might mean for our understanding of reality. They see if it fits within the mathematical frameworks we have. Some theoretical models of cosmology, for example, involve the idea of a multiverse. That means our universe is just one of many. Some of these models suggest that new universes could branch off from existing ones, or that they could tunnel into existence from nothing. These are highly speculative ideas, but they come from trying to solve real problems in physics. Like why our universe is so fine-tuned for life. Maybe it's not fine-tuned. Maybe there are just lots of universes and we live in one where life is possible. So when we talk about making a pocket universe in a lab, we're really asking, can we trigger one of these theoretical processes? Can we engineer the conditions that might naturally lead to a new universe? The answer, for the foreseeable future, is a resounding no. What are we doing that is even remotely related? We're trying to understand the early universe. We're looking at cosmic microwave background radiation. That's the leftover heat from the Big Bang. It tells us a lot about how our universe started and evolved. We're looking for gravitational waves, which are ripples in space-time. These can tell us about huge events like black holes colliding, and we're pushing the limits of particle physics. We're trying to find new particles and forces. All of this helps us understand the fundamental rules. But understanding the rules is very different from rewriting them or creating new ones. Let's think about the ethical side of it too. If we could create a universe, should we? What responsibility would we have for it? If it developed life, would we be its gods? That's heavy stuff. It's like playing with fire, but the fire is an entire reality. What if it went wrong? What if our little pocket universe somehow affected our own? These are questions for philosophers and ethicists, not just physicists, but they become very real if the science ever gets close. The whole concept also challenges our idea of what nothing is. If a universe can come from nothing, or from a tiny point of intense energy, what does that mean for how things start? It's mind-bending. It pushes the boundaries of what we consider possible and what we consider reality. It's important to separate what's currently known science from what's pure speculation. The idea of a pocket universe is on the far end of speculation. It relies on physics that is still theoretical or even undiscovered. It requires technology that is beyond our wildest dreams. It's not something scientists are actively building a lab for right now. No one is putting in grant applications to make a universe. We can create extreme conditions in a lab. We can make plasmas hotter than the sun. We can create magnetic fields stronger than anything in space. We can even create tiny black holes in simulations, but these are not real physical objects. They are mathematical models. We are still learning how to control fusion, which is the power of the sun. And that's just trying to contain a plasma, not create a new dimension. So, to be really clear, no. We cannot create a pocket universe in a lab. Not today, not tomorrow, not in 1,000 years with our current understanding and technology. It's a fun thought experiment. It pushes us to think bigger. It makes us question the limits of physics. But it's not something we are on the verge of doing. It's a testament to human curiosity that we even ask these questions. We look up at the stars and wonder where it all came from, and then we wonder if we could start our own. It speaks to a deep desire to understand creation, to understand existence, to understand if there's anything beyond our own reality. Maybe someday, many, many millennia from now, humans will have advanced so far that they understand quantum gravity. Maybe they'll figure out how to manipulate space-time itself. Maybe they'll find exotic matter or some other way to, get around the incredible energy requirements. Maybe they'll find a loophole, but for now, our universe is the only one we know how to live in. And there's still so much to learn about it. We still have black holes to fully understand, dark matter and dark energy to find out about, and the very beginning of our own universe to piece together. Those are the real scientific puzzles for today. The pocket universe will remain in the realm of dreams for a very long time. And that's okay. Dreaming is where new science often starts, but there's a huge gap between dreaming and doing.